So when you're multiplying, sometimes the multiplication isn't written out for you, like in this first example. This really means 4 times the square root of 72. Joey? Every day. Thank you. Hi, Morgan. Yes. Pardon me just a moment. Would you like to take it outside?
I can take it wherever.
It doesn't matter to me.
That's fine.
I'll bring the gas out for you.
So when you have a problem like this, what we're going to do is we're just going to simplify the square root of 72 and multiply that result times 4. Okay? So again, there's more than one right way to simplify this. Most of you, I think, are doing prime factorization, so I'll do that first, and then I'll show you that if you can think of the other one, it's a lot faster. So what is a prime number that'll divide evenly into 72?
2.
2. All right. So 2 goes into 7 3 times. That'll be 6, so there's 1 left over. And 2 into 12 goes 6 times. And at this point, I'm going to show you a shortcut. Notice 36. What kind of a number is 36? God bless you.
It's perfect square.
It's a perfect square. If, when you're doing prime factors, you come upon a perfect square, you can stop doing prime factors. And you can just do the square root. The square root of 36 is 6. So we've got 4 times the square root of 6 times the square root of 6 times the square root of 2. What's the square root of 6 times the square root of 6? 6. So this is 24 square roots of 2. So if while you're doing prime factors, you happen upon a perfect square, you can just take the square root of that instead of having to just do prime factors. And sometimes that'll save you some time. So for example, let me just show you one. Just watch this one for just a second. If you were simplifying the square root of 128, what prime number divides evenly into 128? 2. And that would be 64. 64, though, is a perfect square, right? What's the square root of 64? 8. So we would have the square root of 8 times the square root of 8 times the square root of 2 is 8 square roots of 2. It's a lot faster if you do it that way. If you don't, on this one, especially when you're dividing 64 by 2, you're going to have a whole bunch of 2's, like 6 of them, after the first 2. This takes a lot less time, okay? So when you're doing prime factorization, if you hit upon a perfect square, just use the square root factors instead of the prime factors. All right. Let's take a look at this next one. We've got 7 square roots of 2 times the square root of 2. Well, what is the square root of 2 times the square root of 2? 2. So this is 7 times 2, which is 14. And that's all there is to that one. Some of them are just that easy. On this one, we've got 11 square roots of 5 times the square root of 3. Yeah, we keep the 11. It'll be 11 square roots of 15.
That's the answer.
That's the answer.
Can you simplify it?
No.
How are you going to simplify?
So if you take the factors of 15, the only two factors of 15 are 5 and 3. None of them are alike, so it's not going to simplify. Okay? So although you can factor 15, it doesn't have any like factors, so the square root is not going to simplify. All right, let's go on. For this one, we'll do the same thing. We'll keep the 12. The square root of 15 times the square root of 3 is?
45.
Right, so that'll be the square root of 45. Now, the square root of 45 can be simplified, because if we factor it, we're going to find it does have some like factors. So this is like the first example now. What is a prime number that divides evenly into 45? 5. 5 goes into 45 9 times. I thought someone said 4.
I was more
You said 4. I said 3.
And then what prime number divides evenly into 9? 3. That'll be 3 and 1. So I've got 12. And I'm going to put the two that are alike first, the square root of 3 times the square root of 3, and I'll group those together. And a square root of 5. So it's 12 times 3 times the square root of 5 is 36 square roots of 5. Okay, so if we have two unlike square roots that we're multiplying together, we just multiply them together and then simplify if possible. So here, we're going to keep the 19. We'll multiply the square root of 6 times the square root of 2 and get the square root of 12. And then we'll simplify the square root of 12. What prime number divides evenly into 12? 2. Goes in 6 times. I'll keep dividing by 2 if I can, and I can, so I will. 2 goes into 6 3 times. 3 goes into 3 once. So I've got 19 times the square root of 2 times the square root of 2. I'll group those. Times the square root of 3. It's 19 times 2 square roots of 3. 19 times 2 is 38, so this is 38 square roots of 3. Yes, sir?
I just say that this really gets my gears going. I love these problems.
You like
These
these?
problems are so fun to make.
These are your favorite?
I mean, I don't like math, but this is keep going.
So this is a skill that you're going to then use starting on Friday's lesson. So you have to have this skill. We're going to do one more on here. I'm going to have you do one on your own. So I want you to do 16 square roots of 14 times the square root of 2. Everyone do that one on your own, please. Wow, that's hard to read upside down. Yeah. Good. Yes. 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 Yes.
I'm not done.
That's okay. So 7 is divisible by 7. 7 is a prime number. There you go. Yeah, keep going. You're doing great.
32 squares.
That was quick. It was a pretty short quiz. Next week's quiz, like 3 times as long. Seriously. Thank you, ma'am. So hopefully when you multiply those two together, you got 16 square roots of 28. And then you went, okay, let's see if we can simplify the square root of 28. 2 goes into 28 14 times. 2 goes into 14 7 times. 7 goes into 7 once. So I've got 16 times the square root of 2 times the square root of 2 times the square root of 7. It'd be 16 times 2 square roots of 7. It's 32 square roots of 7. Before we move on to the next page, let me just point out there's several steps in this. I will expect to see your work. Okay, occasionally at this point I have someone who decides I'm going to do this on some cases mythical, but some cases real, piece of paper, and I'm just going to write down the answer. Please don't do that. You will not get credit for your homework. Okay? Show what you're doing. All right, let's move on. Dividing and simplifying. Okay, with dividing, there's one additional rule that we have with division, and it actually comes from something from a long, long, long time ago that's not really important all that much anymore, but we still do it. And it is that simplified expression cannot end with a square root in the denominator. So no square roots on bottom in the final answer. So for this one, the very first thing I do is rewrite it as 17 square roots of 2 over the square root of 2 instead of just a horizontal divided by. God bless you. Man, those are good ones. My dad would approve of that. So, what is the square root of 2 divided by the square root of 2? 1. A number divided by itself is 1. What's 1 times 17? 17. Some of them will be that easy. Not all of them, but some of them. Is that a question?
Yeah. I have a question. Is another name for this topic surds?
I'm sorry?
Another name for this topic is surds.
Say the last word again.
Surds. S-U-R-D.
What?
Never heard of surds.
He calls some things different things. Like one like ping pong, he calls it paddle.
I've heard of done this topic before, and it was way harder now with season.
Okay. Yeah, I just had never heard it called that. It may be, but not that I know of. All right, let's try this next one. This next one is also pretty easy. We've got 84 square roots of 15 divided by the square root of 3. Okay?
Divide by 3.
Divide what by 3?
Square root.
So the ones that are both square roots we can divide. How many times does 3 go into 15? 5 times. So when we divide the square root of 3 into the square root of 15, we get the square root of 5. And that's it.
Oh, that's the answer?
84 square roots of 5.
So something doesn't divide evenly. Just do that.
Yep. This one is really easy, and I find that students, after I teach them the next thing, tend to forget this one. So hang on to that. It's an easy problem. Don't let what I'm about to show you push this out.
Oh, how do you do this one?
Yeah, how do you do this one? Well, let's take a look. So I've got 16 divided by the square root of 2. I'll start by writing it as a fraction, just like I did with everything else.
2 square root of 16?
No. But it's not a bad idea.
If you multiply by something.
Okay, just hang on for a second. All right, so can I divide the 2 into the 16?
Yep. Yes, you
Well,
can,
no,
bro.
because,
Should I?
No.
Maybe.
Because
Yes.
they're both not like terms.
They're not so.
One-
They're not.
So values are like
Yes.
one is a square root and the other one is not.
not like terms.
Not quite, but I understand what you're saying, and it's not the worst thing I've ever heard. So, yeah, they're not the same kind of number.
Oh.
You can't divide that.
What's the square root of 2?
Approximately 1.414, but it doesn't have an exact answer. So if I was trying to divide it out, that would take it would take a very long time, right? So here's what we do. We do a process that's called rationalizing the denominator. And before, gentlemen, please. Before I show you how to do that, we just need to talk about, well, where did it get that name? So it's rationalizing. You're like, wait a minute, is the denominator not rational now? The square root of 2 is not a rational number. So you're like, well, what's a rational number? All whole numbers are rational numbers. All fractions, where you have a whole number over another whole number, those are rational numbers. All decimals, where it ends eventually or it's a repeating decimal, those are rational numbers. But the square root of 2, it goes on forever. It starts off 1.414 and then it goes and goes and goes. There is no end. Okay? So, how are we going to deal with it? Well, here's the thing. We don't want a square root on bottom anymore. What I'm going to do is multiply the bottom by the square root of 2. And if I multiply the bottom by the square root of 2, I have to multiply the top by the square root of 2 also.
It cancels.
Well, not quite. What is this equal to? It's 1. If I multiply something by 1, do I change its value? No. I may change how it looks, but I don't change its value. So in the numerator, I've got 16 times the square root of 2. Okay. That's 16 square roots of 2. In the denominator, what is the square root of 2 times the square root of 2? 2. Now I have a rational number in the denominator. I have rationalized the denominator. And I can go one step further on this one, because 16 and 2 are both whole numbers. That I can do the division for. 16 divided by 2, God bless you, is 8. So that's 8 square roots of 2. Okay? All right. So let's try this one. 23 divided by the square root of 3. I can't cancel anything, so I'll rationalize the denominator by multiplying by, in this case, not the square root of 2 over the square root of 2, but the square root of 3 over the square root of 3. And thank you for saying it that way. A lot of times students just say, well, you just multiply by the square root of 3. I'm like, that would change its value. You multiply by the square root of 3 over the square root of 3. So we get
23.
23 square root
3
over
3.
3. Will 3 divide evenly into 21?
Yes.
No.
Yes,
Okay.
3 divided 7, but not
No.
3.
Wait,
2
what
plus
you
3 is
say?
5.
Wait, what did you say?
3 into 21 is 7.
Yeah,
3 into,
you said 21.
You said
I said 23.
You said 21.
You said 21.
You said 21.
Did I say 21? I'm pretty sure I said 23, but
You said 21.
if I did, I apologize. So will 3 divide evenly into 23?
No.
No. So this is our final answer. We just leave it like this. Okay? All right.
I'm gonna try this one. Oh, never mind that. Oh,
It's not too bad.
actually.
42 square roots of 2 divided by the square root of 3. What are we going to multiply by in order to rationalize the denominator?
Square root of 3.
Over the square root of 3.
Yeah, the square root of 3 over the square root of 3. And the numerator, what are we going to get?
42 square root.
Exactly right, 42 square roots of 6
Over 3.
over 3. Will 3 divide evenly into 42?
No.
Yes.
No, it won't.
Yes, it will.
Yes.
What's 4 plus 2?
6.
Is that divisible by 3?
Yes.
Then so is 42. 3 goes into 4 one time, with 1 left over. 3 goes into 12 4 times.
14 square root of 6.
So this is 14 square roots of 6.
And do we simplify that, or?
That's as simple as it's going to get. The square root of 6 can be factored, but it's just a 2 and a 3. None of the factors are alike, so it doesn't simplify.
Do we have a quiz today?
No. Next Wednesday, we will have a quiz over simplifying square roots, including multiplying and dividing, which is what we're doing today, and Pythagorean theorem.
Okay. Wait, it's next week and then finals?
Correct.
Oh my gosh.
Yeah,
What are you gonna do over your winter break, Mr. Davis?
as little as possible, hopefully.